Okay, this video is all about congruent triangles. So it is quiz 2.3.3. Okay, congruent triangles are triangles that have the same shape, size, and angle measurements. So those three things, the shape, meaning you can't have a scalene and an isosceles triangle be congruent. Those don't have the same shape. Okay, they're going to have the same size, so all three sides will be equal to the other triangle's three sides. And the angle measurements, all three angles will be equal to the other triangle's three angles. Those are all equal to each other. Congruent triangles, when we name them, so if I say triangle XYZ, XYZ is congruent to triangle, I need to follow the same order of angles. So angle X and angle A match up in our triangles. This one is simply just reflected. So we went from X to Y, so we're going to go A to B and finish up with C. So we continued in the same path through our congruent angles in order to finish naming this or finish the congruent statement. So that's very important that you follow the same order in your two triangles to write out your congruent statement. Okay, congruent triangles have this thing known as corresponding parts of congruent triangles are congruent. In other words, that's fancy and it's often abbreviated by all the first letters of it. In other words, if I have the triangle RST and it is congruent to triangle XYZ, then the angles that match up, like angle X and angle R, they are congruent. So those are our corresponding angles. So I can say angle R is congruent to angle X. I can do that with any of the angles that correspond. Angle S is congruent to angle Y. Angle T is congruent to angle Z. So the angles will always match up and be congruent. We can do the same with a side. So we could say side ST. Okay, we put a little bar over our sides. So side ST is congruent to the corresponding side in this triangle, which is YZ. Okay, so side ST is congruent to side YZ. It's true for the other sides as well. Side RS is congruent to XY. Side RT is congruent to side XZ. So that is the corresponding parts of congruent triangles. It's important to also know that no matter how you move to congruent triangles, so if we were able to pick this one up off of the whiteboard and I were able to move it over here, let's say, that would be a translation. If I just took it and slid it over here, I'm translating it. It is still congruent to triangle XYZ. Now if I take triangle RST and I flip it, a lot like triangle ABC looks as if it has been done. So I take this and I flip it around, flip it over so I cause a reflection, then it is still congruent to triangle XYZ. So no matter if I slide it or I reflect it, so I translate or I reflect, it's still congruent to the triangle. The shape, the size, and the angle measurements have not been altered. So it remains the same congruency. The third type of transformation that we can take is if we rotate that. So if I just flip this over, my triangle is still going to be congruent. So reflection, translation, and rotation will keep two triangles congruent. Anything like a dilation where we make the triangle larger or smaller, that messes with congruency and they will not remain congruent. So the first three that I mentioned, the translation, reflection, and rotation keep triangles congruent, but dilations do not. Okay, that is pretty much the entire thing. Oh, the transformations also maintain the perimeter and area. The transformations of translation, rotation, and reflection will keep the perimeter the same and the area the same as well. That's part of the congruency. Okay, if you have any other further questions, let me know.